projects. In this video, we are going to explain about the project, which is a machine learning framework for early stage detection of autism spectrum disorder. Introduction of the project. Autism spectrum disorder is a complex neurodevelopmental disorder significantly impacting the daily lives of those affected. It manifests in diverse ways, influencing social relationships and behavioral patterns, thereby posing challenges for affected individuals in various aspects of their routine. Acknowledging the critical importance of timely intervention, the project recognizes that early identification and subsequent interventions can play a pivotal role in mitigating the severity of ASD. Early interventions are crucial for addressing behavioral challenges and fostering improved communication skills in affected individuals, thereby positively influencing their overall development. The project proposes a novel machine learning framework designed specifically for the early detection of ASD. This framework leverages a combination of feature scaling strategies and classification algorithms to enhance the accuracy and efficiency of ASD identification, offering a promising avenue for improving the diagnostic process. To ensure the applicability and robustness of the proposed framework, the project conducts evaluations on 4 standard ASD datasets representing different age groups, which are toddlers, adolescents, children, and adults. This comprehensive evaluation allows for insights into the framework's effectiveness across various developmental stages. Through rigorous evaluation, the project aims to identify the best performing classification method and feature scaling techniques within the machine learning framework. This involves assessing the effectiveness of different algorithms and scaling strategies to pinpoint the most accurate and efficient approaches for early ASD detection. Objective of the project. The goal of the project is to create an effectiveness and adaptable machine learning framework tailored for early detection of autism spectrum disorder that incorporates state-of-the-art feature scaling strategies and classification algorithms. Conducting thorough evaluation and assessments of the proposed machine learning framework using diverse standard ASD datasets representing different age groups, which are toddlers, adolescents, children, and adults, to ensure its effectiveness and the applicability across various developmental stages. The other aim is to systematically evaluate and compare the performance of different classification algorithms and feature scaling strategies within machine learning framework to identify the most accurate and efficient technique for early ASD detection. Utilizing feature selection techniques to rank the importance of attributes within ASD datasets, aiming to identify key risk factors and influencing features associated with ASD. This step contributes valuable insights to assist physicians in accurately diagnosing and understanding the disorder. To implement this project, we need software and hardware requirements. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Due to this project, we have designed various modules in the flow of work. So the first module is importing the packages. This module involves importing necessary Python packages and libraries that will be used throughout the project. The packages include NumPy for numerical operation, Pandas for data manipulation, Seaborn and Matplotlib for visualization, sklearn for machine learning. The second module is exploring the dataset. This module involves loading and exploring different datasets related to ASD screening for various age groups. And the datasets are adult screening, toddler, adolescent, and child data. This includes checking the structure of the data, understanding variables, and gaining insights into the datasets. The next module is data processing. This module focuses on preparing the data for analysis. Tasks include removing duplicate entries and addressing missing or inconsistent data through cleaning operations. The next module is visualization using Seaborn and Matplotlib. In this module, data visualization libraries like Seaborn and Matplotlib are employed to create visual representations of the datasets. This step aids in understanding the distribution of data and identifying patterns or trends. The next module is label encoding. This involves converting categorical variables, which are strings, into numerical format. Label encoding is a common technique used in this project. The next module is feature selection. This step involves identifying and selecting the most relevant features for model training. This step helps in enhancing model performance by focusing on key variables. The next module is appending selected features to X and target column to Y. This step involves structuring the data for model training by separating feature as X and target variable as Y. The next module is splitting the data into train and test. This module involves dividing the data set into training and testing sets. This is crucial for assessing model's performance on unseen data set. Coming to building the model, this involves constructing a machine learning model for predicting ASD, and the 4 different techniques which are used for building the model are quantile transformer, power transformer, max ab scaler, normalizer. So coming to quantile transformer, it is a feature scaling technique used to transform features and ensure that they follow a uniform or normal distribution, addressing non-Gaussian distribution in the data. It contributes to the optimization of data for machine learning model training. The next technique is power transformer. This technique applies power transformers to the data, making it more Gaussian-like. It enhances the performance of certain machine learning algorithms, and it is employed in the proposed system for preprocessing. Coming to max ab scaler, it is utilized in this system to scale features, each feature by its max absolute value. This ensures that features have consistent scales, an essential step for certain machine learning algorithms. Coming to normalizer, it is incorporated into the pre-processing pipeline of the proposed system, normalizing each data point to have a unit norm. This is a common technique when the magnitude of individual samples is significant for the model. As an extension, we have applied an ensemble method that combines the predictions of multiple individual models to produce a more robust and accurate results, and also final prediction. Coming to training and building the model, using the pre-processed data, the machine learning model is trained on the training set, learning patterns and relationships within the data. The next module is Flask framework with SQLite for sign-up and sign-in. Integrating Flask, a web framework for Python, along with SQLite, a lightweight relational database to implement user authentication functionalities such as sign-up and sign-in. The next module is User gives input. User interact with the application by providing input relevant to ASD prediction. The next module is pre-processing user input and model prediction. The user input is pre-processed using the same steps to apply to the training data. The trained model is then used to predict the likelihood of ASD based on the provided input. The last module, which is final outcome, is displayed. The model's prediction or classification outcome is displayed to the user, indicating the likelihood of ASD based on the input provided. Algorithms which are used in this project are AdaBoost. It is short form of adaptive boosting. It is an ensemble learning technique that combines the prediction of weak classifiers to create a strong classifier. It assigns weights to misclassified instances, allowing subsequent weak learners to focus more on the difficult cases. AdaBoost is effective for handling imbalanced data sets and improving the overall classification performance. Its adaptability makes it suitable for capturing complex relationships within ASD datasets. The next algorithm is random forest. It is an ensemble learning method that constructs a multitude of decision trees during training and outputs the mode of the classes or mean prediction of the individual trees. Random forest is robust and handles high-dimensional data well, and it is less prone to overfitting. Its ability to capture feature importance makes it valuable for identifying relevant factors in ASD detection. The next algorithm is decision tree. It is a tree-like model where an internal node represents a test on an attribute, each branch represents the outcome of the test, and each leaf node represents a class label. Decision tree provides a clear visualization of decision-making process. They are interpretable and they can reveal key factors contributing to ASD prediction, aiding in the identification of crucial features. The next algorithm is KNN, which means K nearest neighbor. It is a non-parametric algorithm that classifies a data point based on the majority class of its K nearest neighbors in the feature space. KNN is valuable for identifying patterns in data without assuming a specific function form. It can capture local relationships within ASD datasets that might not be evident locally. Coming to naive Bayes, it is a probabilistic classifier based on Bayes' theorem with an assumption of independence between features. It is computationally efficient and works well with the high-dimensional datasets. Its simplicity speed makes it suitable for the initial exploration of the ASD data. Coming to logistic regression, it is a linear model for binary classification that predicts the probability of an instance belonging to a particular class using the logistic function. Logistic regression is interpretable and provides insights into relationship between features and likelihood of ASD. It serves as a baseline model for binary classification tasks. Coming to support vector machine, it is a supervised learning algorithm that finds the hyperplane that best separates classes in a high-dimensional space. It is effective in handling complex decision boundaries. It can capture non-linear relationships in ASD datasets, potentially improving classification accuracy. Coming to LDA, which is linear discriminant analysis, it is a dimensionality reduction and classification technique that finds linear combination of features that best separates the classes. It is useful for reducing dimensionality and highlighting discriminating features. It can enhance interpretability and may aid in identifying critical factors in ASD detection. We have evaluated this project using different error metrics which are accuracy, precision, recall, and F1 score. So here we have quantile transformer comparison graphs for adolescent dataset. This is the accuracy score comparison graph where x-axis represents accuracy score and y-axis represents algorithm names. Accuracy is a metric used to measure the overall correctness of a classification model. It is defined as a ratio of correctly predicted instances to the total number of instances in the dataset. This is the precision score comparison graph where x-axis represents precision score for each algorithm and y-axis represent algorithm names. Precision is a metric that quantifies the accuracy of positive predictions made by a model. It is defined as the ratio of true positive predictions to the total number of positive predictions, which are true positives and the false positives. This is the recall score comparison graph where x-axis represents recall score of each algorithm and y-axis represents algorithm names. Recall is also known as sensitivity or true positive rate. It measures the model's ability to correctly identify all relevant instances in the dataset. It is defined as a ratio of true positive predictions to the total number of actual instances, which are positive instances. Here on x-axis we have F1 score of each algorithm and on y-axis we have algorithm names. F1 score is a metric that combines both precision and recall into a single value, providing a balance between them. It is the harmonic mean of precision and recall, and it is particularly useful when we want to strike a balance between minimizing false positives and false negatives. These are the power transformer comparison graphs for the adolescent dataset. These are max ABS scalar comparison graphs of adolescent dataset. These are normalizer comparison graphs of adolescent dataset. This is quantile transformer graphs for adult dataset. This is for also adult dataset, which are power transformer comparison graphs. This is max AB scalar for adult dataset. This is normalizer comparison graphs for adult dataset. Similarly, we have for other two datasets also. To execute the project, first we need to open the code folder which contains source code files. So this is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Here we have dataset folder. In that we have four datasets, and that will be used for training the algorithms. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And this is the signup.db file. This file is the database file used to store the user information. And this is the model file. This file contains the information which is algorithm information which will be loaded into the project code during runtime. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change the current directory to the code folders directory. So here we need to type Python space app.py, and now we need to click on enter. This will compile app.py file, and this command will execute the Python script and perform any runtime check for any syntax errors or logical issues. After running the app.py file, the Flash framework will host the application locally at the local host and the port unless configured differently. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link now. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project which is displayed in the browser, and this web page is built by using the Flash framework. Here we can see a sign up link. First we need to click on that, and here we need to enter all the sign up details if we are signing up new. I have already signed up and I have an account in it, so I'll directly click on sign in. Here we need to give our credentials to sign in, so I'm giving my username and the password. And now we need to click on sign in. We have signed in successfully. Here we can see predictions based on 4 datasets. So we have created predictions based on this all 4 datasets. So first we will predict on adolescent dataset. Here we need to enter all these parameters and then click on predict. So now we will enter all these parameters. So the A1 is no, A2 is also no, A3 no, A4 no, A5 is yes, A6 is yes, A7 is also yes, and similarly A8, A9, A10 is also yes. Gender is male, and the ethnicity is Hispanic, and the person has jaundice. He has also autism, and the country he belongs to is Austria. He has not used the app before, and he is in between 12 to 16 years, and relation is parent. Now we need to click on predict. So here it is predicted that the person has no ASD based on the given input provided. Now we will give other set of parameters. So A1 is yes, A2 is yes, A3 is yes, A4 is yes, A5 is yes, A6 is no, A7 is no, A8 is no, A9 is no, A10 is also no, and the gender is female, ethnicity is Asian, jaundice, he has no jaundice, no autism, country of residence is Australia, he has used the app before, age description is 12 to 15 years, and the relation is related. Now we will click on predict. So it is predicted that the person has no ASD based on the given input provided. Now we will check with the other dataset. So I am selecting adult screening dataset. So the A1 value is yes, A2 is also yes, A3 is yes, A4 is also yes, A5 is no, A6 is also no, A7 is yes, A8 is no, A9 is no, A10 is no, and the age is 26 years, gender is female, ethnicity is white European, he has no jaundice, no autism, country of residence is US, which is United States, and he has not used the app before, and the result is 25, age description is 18 and more, relation is self. Now we will click on predict. Based on the given input, it is predicted that the person has ASD. Now we will try with the other dataset. So we'll try with children dataset. Now we will enter all these parameters. So the A1 value is yes, A2 is also yes, A3 is no, A4 is also no, A5 is yes, A6 is yes, A7 is no, A8 is no, A9 is yes, A10 is yes, and the gender is male, ethnicity is others, he has no jaundice, no autism, he belongs to Jordan, so we'll search for the Jordan here. He hasn't used the app before, and the age description is 4 to 11 years, relation is parent. Now we will click on predict. So based on the given input, it is predicted that the person has no ASD. Now we will try with the other data set, which is toddler form. So the A1 is no, A2 is also no, A3 no, A4 no, A5 is also no, A7 is no, A8 is yes, A9 is yes, A10 is no. And the age is 28, age in months, which is, and the Q chat 10 score is 3, gender is female, ethnicity is Middle East, he has jaundice, family members, no family members. So now we will click on predict. We haven't choose this parameter, so we will choose it. So it is yes. Now we will click on predict. So based on the given parameters, it is predicted that the person has ASD. In this way, if we give the parameters, which means the features based on the persons, we will get the predictions, whether the person has ASD or not. Conclusion of the project. The project has successfully introduced an innovative machine learning framework for early detection of autism spectrum disorder, showcasing a blend of advanced algorithms and feature scaling strategies. Through the rigorous evaluation on standard ASD datasets representing toddlers, adolescents, children and adults, the framework's robust performance across diverse age groups underscores its versatility and potential clinical applicability. It identifies optimal classification methods and feature scaling techniques within the framework, offering a refined and effective approach for early ASD detection with potential implications for timely interventions. Leveraging feature selection techniques, the project provides insightful attributes ranking, highlights key risk factors and influential features crucial for understanding the complexities of ASD, supporting accurate diagnosis.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.